So we're here this morning on the Donna the Astronomer podcast, and I have the most amazing Dr. Padma Yanamandra-Fisher. Did I get that right, Padma?
Oh, yes, you did.
And
it's all
Padma,
A's, Donna.
I aced it. That's good. Padma and I have known each other for a number of years now and been involved in a number of PACA projects, which we'll talk about later, but are public projects. And here we have some information coming up on the screen telling us all about Padma. So I might let you now talk, Padma, and tell us all about all these exciting things you've done.
All right. Thank you, Donna. And thank you for the invitation. I really feel very proud and honored when people ask me about how I got to where I got, because, you know, most of the time, listening to a lot of people, I feel you have to be destitute or void of all these opportunities. But I have to admit, I was a very lucky person. My parents always insisted on giving the best education they could, allowing us to study as far as we wanted to go. So I was able to get my PhD in India, thanks to my father and my mother's support. And also I got into astronomy primarily because my dad and my mom, when we used to sleep at night on the terrace, looking at the beautiful stars above us, they would tell me all sorts of stories. And I would think, hey, if this is what they tell me here, what would I hear in a different country like the US or somewhere else where they see the same stars, but you know, the stories aren't the same. And so that's how my love for just general astronomy and sharing stories started. And then eventually when I finished my education, my father he was basically in India, you get your bachelor's degree and they say, okay, you're ready to get married. Let's find you a bridegroom. Whereas my parents said, how far do you want to go? And just so happened, I wanted to get a PhD after I finished my master's because I wanted to work with UNESCO and UNICEF. And so they needed a PhD as a requirement. So I said, okay, good, I'll go get a PhD and then I'll look into a job or I'll worry about it then. So just so happened, my parents did agree to all that, but they also put some constraints that I could only go where I had relatives. So I chose Denver. My uncle lived in Denver. My parents were satisfied on that aspect. And the nice thing about Denver is it was basically they had a professor who was working in plasma physics, which was my pet passion when I first came to the US. And so I just lucked out that I was accepted into a place where my parents felt comfortable I could go. I had relatives, they took care of me, and all I had to do was to go to classes and come home and study. So I just was very, very lucky. The only thing, my PhD took a little longer than I wanted because I changed my topic several times. There's just too many things to study out there, Donna. So by the time I focused and settled on my topic, it took me a few years, longer than a normal average student. But I did get my PhD, and wouldn't you believe it, just at that time, Voyager, the spacecraft Voyager, was going by Saturn. And we had seen these beautiful pictures being downloaded, and with the Carl Sagan narrative at University of Colorado, which is not too far from University of Denver. And studying that, I just fell in love with wanting to study the rings of Saturn. So when I finished my PhD, I got a postdoc at JPL, Jet Propulsion Laboratory in California, to study planetary rings with the second spacecraft, Voyager 2, as it went by Saturn. And lo and behold, that started my space career, so to speak, astronomy career. I've had a lot of setbacks along the way, but I've also had a lot of fun and a lot of milestones. And one of the things, I don't know if it helped or hindered me, is I always was the outlier. I was always the one woman in a group, or the unmarried woman who came from India, whereas everybody comes married to their husband. I came unmarried first, and then my parents are all into, oh, let's find a husband for you type of thing. But I was too busy getting started in my own career. And so I did my postdoc at JPL, and then immediately became a staff scientist there because Voyager had by then gone on to Uranus and Neptune, the outer solar system. But then around that time, Cassini was about to launch, and I wanted to be part of a Cassini team to study the rings of Saturn in a wavelength that hadn't been done before. Unfortunately, I didn't get selected for the planetary teams, ring teams on Cassini, but I did end up working with in the mid-infrared, observing Jupiter and Saturn's atmospheres with somebody who was the only person in the world, Glenn Orton, who observes the planets in the infrared. And that is tough to do because you're really using a lot of the sunlight information, etc., like a lot of people do in the near infrared. But in the mid infrared is the thermal emission that comes from the object itself. So you'll try to probe the atmosphere, the variability of the atmosphere, other scattering properties, as well as its temperature by studying the mid infrared observations. It's like probing our temperature, essentially by putting a thermometer in our mouth. The mid-infrared observations do the same thing for planetary atmospheres. And not a lot of people do that in the world, believe it or not. And so, in fact, there are very few telescopes that do that. Most instruments go out until the near infrared, which is around 2.5 microns, because you have so many water bands in the atmosphere that your signal is pretty much lost until you go out to the mid infrared, and then it becomes expensive to build those kind of filters for amateurs. Even for telescopes, many of them don't want to invest in it because they don't have a lot of people who will actually apply for the time. So it's a loss leader for many people, but for us, that is what keeps us occupied. So I did that, and then eventually studying planets and all. But I also, as I became more comfortable observing at different wavelengths and in different modes, I started trying to do some kind of outreach as well as some citizen science. And then I went back to my first passion, which was rings. And then my second passion, which is studying the sun by participating in total solar eclipses. Not just the sun, but the sun is fine. It has a lot of fun things you can learn about. But when you look at an eclipse, it's a combination of so many different fields. It's you study a little bit of moon information, geology, earth shine, exoplanets, the sun itself, and then the behavior of humankind as well as animals and your own emotions. So it's a little bit of social sciences, a little bit of earth sciences, a little bit of planetary heliophysics, and all put together, it is basically a study of our universe. And I think that's one of the best examples I can give of where I use almost all my skill sets. And so, like I said, I think I'm a very fortunate person, regardless of what my beginnings were. I have had a lot of opportunities. Part of them came about from being the only woman. And the reason I say that is because when you're an outlier, sometimes you have to work really, really hard to be taken very seriously. And when you do that, you meet a lot of the challenges both in your personal life, in science, as well as in your workplace. And when you do all of those things together, sometimes you or you create opportunities for yourself that might not have been, that might not have come to you. And having said that,
I just wanted to ask something. Just because one, you're a woman, we're talking in the 1980s, and two, you're a woman of colour because you're from India, and they brought their own challenges. And also you were single at this time, I take it, at the beginning still. Was that a very, because that's very unusual in that time, particularly in NASA. So that
I marked every box.
Challenge?
You know, the biggest challenge to me was the fact that I was a woman, because everybody expects, well, I had a math professor in University of Denver who said most of the women that came to his class came really to find a husband. And he was surprised that, one, I stayed on in the course. I did pretty well. And in fact, I think I got one of the highest scores in his class. So he kind of said this off the cuff and off the record, but it impressed me to the point that I thought, is that why people come to higher classes? You come to an applied math class, which is very, very difficult in itself. But then if they don't have the intention of really sitting through the whole class but finding the brainy people, then their goal is a little different from mine. Plus, like you mentioned, I was unmarried. I was unattached when I first came. So my parents were concerned about, will I find a guy there? Will I get married? Will I get off my track of getting my PhD? And so I had to walk a very fine line between my parents and I lived with my aunt and uncle and his 3 young daughters. So I had to watch what I did, what I said, because they were worried that, hey, I could be a bad example for their kids if I went off this line. So, and then of course at work, I was on a fellowship, and I could lose the fellowship if I didn't get good grades. And so I had all these constraints, and I had to find my way through all of them slowly. But, you know, all said and done, life happens. And so I fell in love. I married one of my classmates, and luckily for me, he's also into astronomy, more of the amateur type, but still, it gave us some common goals, and I think that helped a lot. The fact that we're classmates and going in the same classes, I don't think sat well with a lot of my professors, but in hindsight, it really doesn't matter. But at that time, it did. And I was worried about my parents, my uncle, my aunt, my influence on my cousins. There were too many factors that were distracting me from what I should have been focused on, which was my goal of being in UNICEF and getting a PhD in astronomy or in physics. But ultimately, I got my PhD. I didn't go into UNICEF or UNESCO, but where I have been is just as wonderful. And I don't think I'd exchange a lot of my experiences. I would shortchange the time. I would try to do it faster so I could have more time to enjoy it. But I don't think I would have changed any of my challenges, because those challenges really made me feel I could do what I could do. Because no matter what anybody said, it ultimately comes to the point, do you believe in yourself? And it doesn't matter what anybody says. And you'll find that no matter what everybody says about, hey, it's you got to do your best because you are selected on your merit and this and that, that's not true either. You're selected by your presence, people who think you make a good leader. So you're always being judged by somebody else whether you can do that job. And if you let other people always tell you whether you can do the job or not, you're not ever going to do a good job, because you don't have confidence. Your confidence derived externally. And I think that's the wrong message to almost every child.
So a belief in yourself.
I mean, you have to. I mean, at some point, at the beginning, yeah, you don't know what you can do, so you do rely on others to help you find the common blocks of knowledge or whatever you want to do, or find a pathway. But ultimately, you're the one who's going to go through that path yourself, and you're the one who has to come out saying, I did it. And if you can't have the confidence in yourself and your ability, you may not know the answers, but if you don't have the confidence, you're not going to come out knowing that you're going to be able to do this yourself. You'll always be looking for somebody else to lean on as a crutch. And that's what my takeaway would be for anybody. Always look for an authority figure that you can ask help from, but do not depend on anybody but yourself and your confidence.
So what would you say has been the biggest challenge and your biggest success?
You know, my biggest challenge has been working in the shadow of somebody. And I say that not lightly or to demean anybody or to be derogatory. But sometimes I look back on my career and I think, you know, I could have been this, I could have been that. And yes, I could have, but I didn't, because I chose certain pathways where no matter what, the scientific world always saw me as somebody working in somebody's shadow. And their confidence in me didn't stem about from what I did. It stemmed from the fact that I was working with somebody that they knew could get the job done. And in the beginning, that was fine. But later on, it hurt because you couldn't ever be independently funded or independently taken seriously. Then, of course, you have the female aspect of it. Then you have your husband. So then, you know, you have to say, oh, let me check with my husband. Then it's like, okay, you can't take an independent decision because you have to talk to your husband. So slowly but surely, what were the milestones and the achievements for me in the early days later on became more of a criteria by which I was being criticized, and it hurt in certain aspects. In other aspects, it didn't. And my biggest challenge and my biggest achievement, I believe, is that every time I bumped into a wall where they said you couldn't do this, I always did it. And I feel my career really spans not just one as a science. If I consider myself a scientist, it's one career. But if I consider myself as a planetary observer, planetary scientist, modeler, citizen science, amateur, working with amateurs, then it's like 3 or 4 different smaller careers rolled into one. And the culmination now is I have a lot of science background. I have a lot of what should I say, connections with a lot of the community in terms of educators, astronomers, as well as amateurs. I know a lot of the people who do make the instruments, even if I don't make it myself, so I know what kind of observations we need. And I feel like I can always identify a cutting edge field. Whether I'm a part of it or not is different, but at least I can identify opportunities. And they might be a little too late for me because I might be retiring, or I might have aged quite a bit compared to a younger person who knows how to use computers or new techniques and new modeling techniques. So regardless of what I have achieved, I feel like I know a lot of almost several different fields, and you need that kind of overview of many fields to be a success. And that success you define yourself.
So if you were a young person today, wanting to get into astronomy, wanting to study this field and to do something, particularly because there's so much coming up with Artemis and the Mars missions coming up hopefully later this month, and all, I mean, the future is golden. I mean, this is the golden era of planetary exploration in reality for, so young people today in school, in year 7 or in, well, our early high school, are right on the cusp of something that's beyond anything that we even comprehended when we first started, when we were at school. What would you say to them they should be looking at to try and get into this sort of career?
Well, you know, first of all, you need to have tools. So regardless of what anybody says, you need to know how to program in some language or the other. You can't say, I'll do it in university or in college, because when you do that, it takes time away from something else. And sometimes you can't study the science unless you have a tool like a programming language or modeling or numerical method that you can actually apply. So the tools you need to learn almost all the time with or without the science background. Secondly, you need to have some science. You cannot just look at data and analyze it without knowing a model, without understanding the science. So when people say, oh, you don't need to do all this, you can just become an exoplanet atmospheric scientist, or you can become a data scientist and just look at, there's tons of data we use in other fields. We can use statistics. Yes, you can, but can you interpret the results? Can you interpret the trends? No, you can't, because you don't know the science. So it's not, there's no shortcut in going through the classes. There's no shortcut in understanding. And there is no shortcut to the experience you develop by working with somebody much more experienced than you and established than you. But those are steps along the staircase, right? You first learn your tools, then you graduate, you go into a college, you pick a topic, you learn about it, then you start interning or finding opportunities to get experience. If you finish and do a PhD, then you have to do a postdoc, so you work with somebody well-known in the field. And then you start understanding the science and why these things are done in such incremental fashion. And there's no shortcut to that, but at the same time, you are developing a new field, maybe like data science, for example. The statisticians and astronomers, they never worked together. Now they're starting to, and believe it or not, there's so much you can learn without actually doing any kind of modeling. You can study the language of R, you can do visualization, you can do augmented reality. All of these require more technical, hands-on knowledge about how those tools and technology works. It has nothing to do with science. Yet if you have the science part, you can take the science data and use the augmented reality or science on a sphere, which you project a map of a planet onto a sphere, and you can actually learn. You can actually mine the data, and you can actually learn about it by exploring in real time from your viewpoint versus waiting for a spacecraft to go and get the data for you from another object. So I think today I would say put a lot of emphasis on what are the tools that are cutting edge tools, and try to see how they can apply. And these are wonderful small projects you can do as an internship or as an independent study in your school. Find a professor or a teacher who's willing, even if they don't understand what you're doing, is willing to let you experiment. And when you start teaching your own teacher, you have learned something. And that's the moment I'm always waiting for, to see the students that I hold hands and walk them. And at some point they release my hand and they hold my hand to tell me what they're doing. And I learn from them. So you can never stop learning.
That's the most exciting thing, isn't it? As a mentor and as a teacher, is to be able to see your students progress to the point that they don't need you anymore, but you can learn from them. But I want to add one thing in here. One of the skills that I wish I had developed a lot earlier, being someone who loved maths, loved science, loved all of those things, disliked intensely English, very much disliked English, but it's one of the most critical skills, the ability to write. You know, it's not a joke about publish or perish. And now I'm totally jealous. You actually have an autographed photo here in front of us.
Yes, actually, this is one of the things you're talking about students. And you know what? If you're always learning and you look at the world around you, childlike wonder, then you take a global astronomical event and it sometimes encourages you. You know, this was a stock picture that NASA sent to anybody who was interested in the Apollo 11 crew, that actually the astronauts that went to the moon, landed and came back, right? And I was in India by that time. And so I basically wrote to NASA, and I was very childish. I mean, this is 5th grade, 6th grade, 7th grade, that time period. And NASA sent me the stock picture in which all 3 astronauts, Neil Armstrong, Michael Collins, and Buzz Aldrin, they all signed. And this is a stock picture. So they took a lithograph and made a million copies and they sent it to everybody. But it didn't matter to me that they weren't real autographs. What mattered was that NASA responded. I had a picture. I left it in India somewhere, so I don't know where it is, but I did find this picture. And believe it or not, the fact that they stepped on an object that I see in the night sky every night was so exciting. It just drew me in. I said, why can't I be the first NASA or Indian astronaut? And so that was my goal. That's the reason I actually got into astronomy, because apart from being the first in space, I could also actually do space exploration. But engagement and encouragement takes one little incident. This was a picture that helped me. And it's something I'll never forget. Well, I work on NASA grants, let's put it that way. Now NASA has become a flat institution where you have a lot of managers, but then they give money, that they work hard and they promote certain top projects. And so they get money for you to apply for. And then those are the grants that I work on, yes. And thanks to Glenn, who's also supported me most of my career, between he and I, we have a lot of observing time on the large telescopes in the world. We basically have pretty much nailed all the mid-IR observations of outer planets. And so in that sense, there's a very small community, but we're part of a larger community when you take all the other wavelengths and other objects in the sky into account.
So we might finish on that for today.
Yeah, okay.
If that's okay, because
sure.
We've got something else here, because we want to talk more and more about some of the things you do in another interview later on, if that's okay.
Sure.
But, okay, I'll let you finish this slide, because that looks even, because that's the sort of stuff I'm interested in. It's very interested, because of course I'm interested in habitability of other planets.
I mean, right now we've just been talking generally what are things people should do, and you know, if I have to have a little slogan, I would say always look up. But why are you looking up there? Because you want to understand how you came to be on this earth, on the land that you're standing on. How did you come out? And so NASA in its space exploration has 2 overarching goals, where all your work really is defined by one of the 2 questions: is how did our solar system form? Are we that unique that you know, there are, now that they're discovering so many planetary systems, why is it that we are interested in our own? And secondly, is there a life outside of the solar system? We know there's life on Earth, but where are the other Earths? If you find other solar systems, are there Earths there? And are there different types of Earths? So we just happen to be in what's called the Goldilocks zone. We're neither too hot, too cold, and we rotate, our planet rotates, the atmosphere rotates. So we have a nice diurnal temperature profile. So, but our system, our solar system, if you look at it from the sun outward, some people call Pluto a dwarf planet, some people call it the 9th planet, whatever you want. If you look at we have a huge diversity of rock planets, gaseous planets, planets that didn't form, dwarf planets, planetary rings, comets, asteroids, etc. So when you have such a huge diversity, you have a wonderful laboratory in front of you that you can actually learn from. Secondly, why are we unique? Is there something about our DNA? And if that is the case, how did our DNA come about? And they have found the building blocks of our DNA, which is all the proteins, the amino acids. They actually have found some amino acids in the solar system. So did it just spontaneously combust and come about on Earth? Or did different parts of our DNA, were they carried by some object or the other through impacts or whatever? Like the water is supposed to come from comets, etc. So are the different building blocks of our lives also come about from different ways of transportation? And if so, why is it only that Earth got habitability, but why don't we have it on other planets? So that takes you out, not into esoteric arguments and like before, but now you actually know that exoplanetary systems exist, and there are planets in the planetary systems. And so the variety of planets, and the dwarf planets. So we are starting to get so much more information than we ever did. And even though people say, oh, we already explored solar system. No, that was reconnaissance. That's the basic exploration to know what's out there. Now we are really learning by actually going to each and every object. So this is where I think all research will eventually come back to answering one of these two questions. And from here, you can go to the professionals, the amateurs, the astrophysicists, the heliophysicists, what doesn't matter. You will all be connected by these questions. So that could be a starting point for another time if you like.
I think so, because I'm very excited about some of the stuff that the missions that are coming up, like the Icy Moon missions, and the possibility of the building blocks on Titan and Enceladus, and of course Europa.
Yes.
So I'm very excited by that. So
right, and you're going to the next generation.
Yeah, I wish I was young again. Mind you, I wish I was young again and know what I know now. I don't think I want to go through growing up again.
But you're being very modest, Donna. You discovered 2 comets that I have not. So that's something that I would love to hear from you, the stories of your discovery of these comets. But speaking of comets, though, in about a week, you will have access to Neowise.
We're going to see Neo.
And and you know what? It has several tails, Donna. So if you have members who are into watching comets and have legacy comets data, ask them, go out there, see it, sketch it, but then start observing it, truly observing. So you see the main tail, the ion tails. And today I heard it has another red tail outward of the bluish ion tail. And I don't know the story. There should be a sodium tail. Where's the sodium coming from? So there's so much to see. Compare it with Hale-Bopp, compare it with Lovejoy. I mean, there's so many comets that you can select. And they say there's a poor cousin of Comet West. Look up what Comet West was. So you're going to be in for a lot of exciting nights.
Yes, I can't wait till the 26th. And it better not fade. I'll be most disappointed if it fades. But then, having said that,
I know.
I did get to watch 2006 B1 Sighting Spring, Comet McNaught, the comet of the century, at its glory. So,
yes.
Being in on from the discovery.
Yeah, I wish I could have seen that head. Yeah. I wish I could have seen that headless comet, as they're called, Comet Lovejoy, that the tail just came up, rose, but there was no head there. And I cannot imagine a comet without a head, That is something I would love to see. So, but I was very, very pleased. I actually saw it naked eye before this comet was discovered, in the sense that the tails weren't, people were just showing the main tail, and maybe some people are showing the ion tail. But I saw it just before that. So the other tail hadn't really developed. And I haven't gone out again. It's now supposed to be available in the northwest by the sunset twilight. I haven't gone because we don't have a low horizon. I have to go really, really far. And so I'm not going anywhere right now. But I wouldn't mind seeing it one more time before it fades and goes to the southern hemisphere.
No, at Milroy we have a very good western horizon. So as soon as it's visible, I think everybody in my groups around that time will be having to look at it. It won't be an option.
Yeah, you need to have a star party. Yeah. Plus, you should have a star party and maybe do a live streaming feature so that we can kind of, or go Facebook Live so we can watch it at the same time vicariously through Donna, the astronomer.
Well, that's what I'll be trying to do. Well, thank you so much for your time, Padma.
Sure.
It's
No
it's
problem.
it's 8:30 in the morning here, and so that's what, about 3:30 in the afternoon over there in California.
Yes.
So
Yes,
thank you
it
so
is.
much
It's
for your
about
time.
3:30.
We're going to talk again.
Okay, lovely. And let me know when you want anything, or if I can help with any questions anybody has. Just give them my email. I don't mind it, and I certainly look forward to hearing back from you. And again, good luck looking for that comet. It's going to be spectacular.
And on that note, we'll sign off for today and come back and talk to Padma in a couple of weeks about some more exciting things.